Look like stars. Yeah, because stars fall to the earth. You know?
Okay, chapter 9. So first, way it feels like a long time ago, but it was just Monday. We talked about Pascal's triangle and this other formula for finding the term of a expansion, binomial expansion. So Pascal's triangle, it would be extremely useful for you to know a little bit of that, and obviously how to continue it on by adding the two terms and things like that. But perhaps even more useful than that is the NCR thing. So when you do that, the two numbers that you need are n, which is the same number as the big power in the problem, the exponent, n. And then you need to know r. R is the term minus 1. Term minus 1, that is r. So when we do the expansion, you put NCR, whatever that number is, in front, and then parentheses A, fill it with the first term, parentheses B, fill it with the second term, and then work with your exponents. Your exponents are actually kind of easy. Once you've done the NCR thing, R is the back exponent. The second exponent is R, that exact number. And then the other exponent, they have to add to equal the power, so you can just subtract together. Power minus the number you just wrote there would be the other exponent. So this is out of order, but it's out of order on your review. It's in order with how we learned it. So we're going to skip and start with number whatever. Oh. 13, 15, 17. Close.
12.
12 and 17 would round to the same near 15, which isn't the thing.
You do this every single like how
No.
I don't know, sometimes you like work on a problem and I find it later.
No, I don't know. It's possible I just rearranged the questions for some reason too, if that happened. Okay, what is the 10th term of 3x minus y to the 15th? So 15 is the power, so 15c. R. R is the term minus 1. We're doing 10th term. 10 minus 1 is 9. Then we go to parentheses. 3x negative y. Then we do the exponents. The back exponent is the same as r, so it's 9. And then since the power of this question is 15, the other one's got to be 6 because they have to add to be 15. Or you could just do 15 minus 9. Get that one. It doesn't matter. However you get it, as long as you get it. So all you need to do is work this out.
Oh, never mind.
Yeah. So all you need to do is work this out. Now, this NCR thing, you have to know how to get to it. If you have a TI or a Casio, it's slightly different. TIs, you press the math button. Casios, you press the option button. Probably not. All right, so I've got a Casio up here, so I need to push option after I'm in the actual calculator part. Option. And then no matter which calculator you have, TI or Casio, the next thing you're looking for is probability. It's either abbreviated PRB or PROB. PROB on my Casio.
Yes, that's probably right.
And then there it is, NCR. Now, what you need to remember is you type in the first number first, because it needs to go before the C. So you type in 15, and then the NCR, and then the 9.
I don't know where to find it. Yeah. Oh.
So you should get 5,005. Make sure you try that. Like, do it right now. Make sure you get 5,005. Make sure you know how to find it, how to enter it, and that you get the right numbers. So that number is 5,005. Then we've got 3x to the 6th, which means we need 3 to the 6th and x to the 6th. 3 to the 6th is 729. You can use the calculator again. You've already used it once. You're allowed. And then negative y to the 9th will stay negative because it's an odd exponent. And then we multiply this out. 5,005 times 729 is like in the millions. 364. And then make sure you write your variables. X to the 6th, y to the 9th, and then since there was a negative, this is a negative answer. So you'll have a couple questions like this. There's a few on there reviewing. I think there's at least one more. So we can do one more. This one, though, asks for the entire row. So it might make more sense to just use the triangle rather than type it into your calculator 7 times or something like that. And this one's a little bit mean because it's a 6. So on Pascal's triangle, boom. This is currently for the 4th, so we need to go 2 more. The second number needs to be 6. 1, 5, 10, 10, 5, 1. Uh-oh. 1, 6, 15, 20, 15, 6, 1. There's the row we need. That bottom one I just created. 1, 6, 15, 20. So when we do these, you write each of those numbers with both parentheses. Each of them with both parentheses. I'm writing too big. And then 6, and then 1. Ah. You might need a different piece of paper for it. No, because you'll have a huge space. Like you have like a quarter of a page, like full wide.
Is it okay if we like run out of room and we put in like second part of the afternoon?
Yeah, that'll be fine. I may even give you like half a page for this
Wait,
question.
so the exponent has to be second.
Yes. Yeah, so you know you're using the correct row because the power will match the second number in the triangle. That's the correct row. All right, so we're filling in the 3x and the 2y. And then we fill in the exponents. The first term starts at 6 and counts down. The second term starts at 0 and counts up, or whatever. Oh, I didn't write the negative in it. Thank you. All right, so now we fill in the exponents. First exponent starts at 6 and counts down. The other one starts at 0, counts up. So 6, 5, 4, 3, 2, 1, 0. And Happy New Year, sure.
Thanks.
And then the other one just does the reverse. So you can either start on the right and count down or start on the left and count up from 0. It doesn't matter. The important thing is the two exponents will always add to equal to 6, the power. The two exponents will always add to equal to 6. All right, and now it's just a whole lot of calculation. So 0 power, you can cross those things out because they're not needed. So we have 1 times 3x parentheses to the 6. So we need 3 to the 6, x to the 6. 3 to the 6 is 729. Then we have 6 times 3 to the 5th times negative 2 to the 1st. 6 times 3 to the 5th times negative 2. Negative 2916. And then fill in your variables. That's going to be an x to the 5th and a y to the 1st. Next, we have 15 times 3 to the 4th and negative 2 squared. 3 to the 4th is 81. So 15 times 81 times negative 2 squared is 4. It's 4860. X to the 4th, y squared. Then we have 20 times 3 cubed. So that's 20 times 27 times negative 2 to the 3rd is negative 8.
Hey guys, we're still selling bracelets. Does anyone? You do? We're doing question.
15 times 3 squared. So 15 times 9 times negative 2 to the 4th. That would be 16. Positive 16. So 15 times 9 times 16 is 2160. X squared y to the 4th, and then I'm out of space, so I'm just going to continue it on the next line, which is okay.
Is it though?
6 times 3 times negative 2 to the 5th. 2 to the 5th is 32, so negative 32 times 3 times 6 is negative 576. X to the 1st, y to the 5th. And then negative 2y to the 6th. So 2 to the 6th, that's going to be 64. It's going to be positive because it was an even exponent. Y to the 6th. there we go. It's technically all one line. I just couldn't fit it. I will not mark you wrong if you run out of space and do that as well. Sorry. Yep, the whole thing.
That's a scary looking.
There is for sure one problem that you have to do the entire Pascal's triangle row. It probably will not be a sixth power. It'll probably be like fourth or fifth, but it could
I'm
be.
gonna cry. If you see me crying, it's because
I think it's a fourth or a fifth.
he's gonna give me
Yeah, the numbers as a triangle. Like, I don't understand how you got the numbers.
Oh,
Like-
I have my notes. I will show you because that's actually really cool.
All right, let's see what's next. The rest of this is from yesterday and the day before. So we have two other parts to this lesson, or to this chapter:
Oh, no.
arithmetic sequences and geometric sequences and series.
Oh, can't we go over the, oh wait, did I mention arithmetic?
Arithmetic was Tuesday this week, and geometric was Wednesday this week.
All right, you're going over arithmetic?
Yeah.
So,
So arithmetic,
what was arithmetic?
as an adjective, I pronounce it arithmetic
Okay,
because it's an adjective.
all
Okay, for arithmetic sequences or series, we have a couple of things. You can find a term. Or you can find a sum. The sum is, we talked about, we built it up as the, like imagining the line of numbers and folding it in half. We talked about Euler when he was a kid, the folk tale that goes with it. All right, now the last maybe two formulas that you might need from these are definitely optional formulas. If you just know your stuff, you don't need these. But if you have a hard time finding D, you subtract two terms. It's the difference between the second term and the first term. That really shouldn't be a difficult thing for you. And if you have a hard time finding this A sub 0, just take the first term and subtract D from it. So those are kind of optional formulas. I don't usually include those as formulas because for the most part, you just remember them because it's a little bit of common sense.
You said you were going to provide these formulas?
Yeah.
And the ones from Pascal's triangle?
Yeah, everything I put on this slide, I'll provide.
Oh, dope. Love that. Thank
All right, so here's arithmetic. Arithmetic, you get the terms by adding the same thing over and over again. That is D. So this one, that does not look like adding. I cannot think of a number that you would add to 3 to get to 3/5 and then the same number to get to 3/25. So let's skip that
you. It's imaginary number.
until we talk about geometric. How about this one? Is this adding?
Geometric.
That looks to be geometric also because it looks to be multiplying by -2 each time. So let's skip that. This one also appears to be multiplying by -1, so not adding. All right, this one doesn't quite look like it's arithmetic, but it might be. So an arithmetic sequence adds the same thing over and over again. You can think of a 5 or rewrite a 5 as 15 over 3. And now it's actually a little bit easier to see that this is arithmetic because the denominator is not changing and the numerator is going up by 7 every single time. So it is adding 7 over 3 every time. It is arithmetic. It's a little bit complicated, but it is arithmetic. So for the arithmetic sequences, we talked about those, the 4 first variables that you need, or the things you need are nada. We do not know n because we're trying to write the formula for the term. Explicit formula means term. The term formula. So we do not know n. We do know a1 is 5. Or you could say 15 over 3 if you wanted to, but that's weird. D, we already found is 7/3, which means a sub 0, that's a little difficult to just magically come up with, but if you use the formula we wrote down, that a sub 0 is a1 minus d. Going backwards from 15/3, subtracting 7/3, you would get 8/3. That is a sub 0. Yeah, from the numerator. Yep. Subtract 7 from the 15 since they have the same denominator. All right, so our explicit formula is the term formula, which is d times n plus a sub 0. D times n plus a sub 0. That is your explicit formula. Now, calculate the given term. It wants us to find term number 31. So to find a sub 31, we have to plug 31 into this formula. 7 over 3 times 31 plus 8 over 3. Calculator time. So it'll be 225 over 3, which is 75. So at least it worked out to be one of the whole number terms instead of fraction terms. Yeah, 225 divided by 3, and then that gets you 75. So there was 2 questions hidden in there. Make sure you caught that and answered both questions. Number 9, find the sum of the first 31 terms. So that's the other formula, the sum of the first 31. So in order to find the sum, that's n divided by 2, a1 plus an. We know all these things already. We found them all in this first part. We know n is 31, so it's 31 over 2. The first term was 5. The 31st term we just found was 75. Calculator time. The sum is 1,240. All right, so that's arithmetic. We're going to go backwards a little bit. We're going to go back to the notes. We're going to talk about geometric real quick, and then we'll do some more examples. All right, so those were arithmetic sequence and series formulas. Now we'll talk about geometric. So just like before, we have the equation for the term and the sum. Those are the first two formulas from yesterday. The term was a sub n equals a1 times r, and then the exponent is n minus 1. And then we had that sum formula, which was kind of complicated. A1 times 1 minus r to the n over 1 minus r. So within this, there is a little calculation for r if you need it. You just take the second term divided by the first term. Or you can up those numbers and say the third term divided by the second term, or whatever. But there is also one slightly different thing about sum, because there's two sum formulas. There's sum of the first n terms, and then there's sums of the entire thing. So the infinite sum have a weird infinity.
Why would you find it like
I don't know, I messed up halfway through, and that's what I ended with. It looks like somebody's staring that way.
Hey, yo, that's actually kind of. I feel like it's actually kind of good. We should be an artist.
Yep, totally.
All
All right, so the infinite sum is almost the same formula, just without the parentheses. It's just a1 over 1 minus r. It gets a little simplified, even though the concept is more complicated. Now, with the infinite sum, you do have to remember that if the absolute value of r is less than 1, it converges. And if the absolute value of r is greater than or equal to 1, it diverges. So you have, if it diverges, that just means you cannot find the sum. Can't do it.
Is all this going to be up tomorrow? Like,
Everything that I've written on this page will be given.
So you're telling me I didn't need to buy that $8 bracelet that I now have to pay back my friend for?
Hey, you got a kid bracelet though.
He tricked us.
I told you I was giving you some formulas.
I thought you
I-
said
yeah.
write down the names.
No, yeah, you guys
Yeah.
can still put down a lot.
Yeah. I don't regret it.
All right.
You're not gonna be able to see any white left on the card. It's just gonna be all pencil.
Find the sum. So this one earlier we talked about this was going to be a geometric because it's multiplying from one term to the next. So it is geometric. And then the dot 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 means it's going to infinity. So it's the infinite sum, which means we need to know a1 and 1 minus r. We need to know a1, we need to know r. A1 is right there, it's 3. R is the thing that's being multiplied over and over and over again. To get from 3 to 3/5, notice how the numerator is not changing. So the numerator of R has to be a 1 because the numerator doesn't change. The denominator changes. It's being multiplied by 5 each time. Fractions, you can look at the numerator and denominator separately to find R. 1, 5, 25, that means it's being multiplied by 5. So R is 1/5. So this calculation, simplify top and bottom, that's going to be 3 over 4/5. Flip and multiply. That's 3 times 5/4, which is 15 over 4. There's your sum. The infinite sum. All right, number 2. Again, dot, dot, dot. Goes on forever. We're finding the infinite sum. So we got to find R because the infinite sum formula is A1 over 1 minus R. We need to know A1, which is 4. We need to know R, which to get from 4 to -8 to -16 is being multiplied by -2 every time. And then we can actually stop because R is -2, which means the absolute value of R would be 2, which is greater than or equal to 1, which means it diverges, which means we cannot find the sum. We just say it diverges. So find the sum if possible. It's not possible because it diverges. And all you got to say is it diverges. Or just diverge. Not always when it's a negative. It's just if it's bigger than or equal to 1. Ignoring the negative. Yeah. We'll get it tomorrow. All right, number 3, find the sum of the first 147 terms. So n is 147. Is it geometric or arithmetic? Geometric. What is it being multiplied by then? Being multiplied by -1 every single time.
It's just 5. Okay, never mind.
So A1 is -5, R is -1. The first term's -5 and it gets multiplied by -1 over and over and over again. For the formula, sum of the first 147, so that's n. Sum of the first n is A1 times 1 minus R to the n over 1 minus R. That's the formula. Now we plug stuff in. A1 is -5. 1 minus R to the n, -1 to the 147 over 1 minus R. So although this looks a little bit intimidating, having a big exponent, it's just -1 to the exponent. So negative to an odd exponent would be negative. So it's going to stay -1. 1 minus -1 is really 1 plus 1. So this is -5 times 2 divided by 2. Which is -5. Since it's odd, it was just going to be a -1.
Oh, okay.
Now, by the way, your only options for a sum on this one, like if you keep adding up the terms, you're either going to get -5 or you're going to get 0, like depending on where you stop. Just because it's -5 plus 5, -5 plus 5, like you're either going to stop when you stop adding up, you're either going to end on a -5 sum or a 0 sum. So it was almost just 50-50. Could have just guessed almost, but don't guess. Use the formula. All right. The word problem, kind of the same idea. You just have to interpret it into numbers. So this says the company pays you $50 for your first sale, and then an additional $12 for each sale after that. So the first time you make a sale, you sell a phone, you get 50. Your second, you're going to make an additional $12. So not just $12, but you get the 50 and the 12, so 62. The next phone you sell, add 12 again, and then add 12 again. Now, since I kind of just gave it away, we're adding 12 each time, which means it's arithmetic and D is 12. So arithmetic, nada. D is 12. The first phone you sell, we made 50. The first term was 50. Theoretically or hypothetically, the term before that would have been 12 less than that. So 38. How much do you get for the 10th phone? And then how much money did you get altogether? So the 10th phone and it's 10.
But doesn't it say no matter what the first one is $50?
The first phone is 50. Theoretically, before you sold anything, that means you got like, it's like getting $38 plus $12 for every phone. So you get, it's like getting a flat 38, but then you sell your first phone, they give you 12. And then you sell your second phone, they give you another 12, like on top of it.
So they just give you a 30 everything?
Yes. As long as you sell a phone, yes.
Is all companies? Yeah, commissioner.
I have no idea, actually. I feel like Verizon does, because when I go in there, they are trying to sell you a new phone like every time. So I feel like they do. I don't know.
Wait, can you remind me what the difference between arithmetic and geometric is? Is it geometric is multiplying and this is adding?
Yes.
Okay.
Okay, so from here, we're trying to find the value for how much money you earned when you sold your 10th phone for that singular phone. So that's A sub n equals A1, no, not A1, dn plus A0. Sorry, thinking of geometric. So A sub n equals B is 12, n is 10, A0 is 38. $120 plus 38 $158. So if you sell 10 phones according to this business model, the 10th phone that you sell, you made $158. I mean, that's pretty good.
It's good, but
Better than the tomatoes.
the thing that if that's all you get, you only get one.
Well, yes, but you also get, so that was just for the 10th phone.
Yeah.
You also had 100 and whatever for the 9th phone, plus 100 whatever for the, so that's actually the next part here. How much do we get altogether? Means because you got paid for the first phone, you got paid for the second phone, you got paid for the third phone, you get all of these numbers added up. All the way up to the 158. We got to add up all those numbers. So that's actually, this is going to be pretty solid money.
And,
Yeah, now
and all the money that you just made, you buy the tomatoes?
You could probably afford a tomato according to the problem. Yeah,
All right, go.
maybe multiple tomatoes.
Oh, no,
How much are the tomatoes?
yeah.
It was like $1,000 to buy a tomato every day.
I think it was like 68,000.
Yeah, it was like 68. It was some weird problem on your homework the other night.
It was a lot.
You missed a few tomato jokes.
All right, so to find the sum, it's formula n/2, first term plus last term. So the first term, first phone, you made 50. The last term is 158. There were 10 sales altogether, so 10 divided by 2. So it's 5 times 208. $1,040, which that would be pretty good pay for like a week. Maybe if you did that in a day, that would be extremely well paying job. I don't know if you could sell 10 phones in a day, but in a week I think you could.
But it also goes up. So, long-time employee, you're making bank.
It's true. Yeah, eventually the company's not making money because then they'd be paying you for every
So
phone.
that's the
So
sum, 1,040.
at a certain point, once you pass that, then it's like just buy yourself all the phones because you make money for every phone that you buy.
Whew.
So,
I mean, you can
just
sell
tell Rice that's not that smart.
Yeah, they probably don't do it that way. That's why they do percentages of every sale rather than like a flat rate. All right, we did that one already. Number 7, find the sum. So in order to find the sum, you need to know what type of series. Is it multiplying or adding? Adding 4, which means it's arithmetic. Nada. We do not know what number term that is. We just know it's 98 over there. We don't know what number term. So we'll have to figure that out here in a minute. We do know the first term is -2. We can see that it's increasing by 4 each time, or adding 4 each time, which means the number before that -2, theoretically, would be -6. So from there, we need to figure out what n would we have to plug into our formula to get 98. No, to get 98. What number do we plug in for n to figure out what is n here? Plus -6, so -6. What number do we need to plug in for n? So add the 6, divide by 4. So this is the 26th term over here. N equals 26. Now we need to find the sum. But you need to know n so that you can find the sum, because the sum formula is n divided by 2, a1 plus an. So that's 26 divided by 2. First term is -2, plus the last term was 98. So that's 13 times 96. 1248. All right, another word problem. So you need to determine what type of series it is or sequence, and then get all the information from it. So if she does 2 pull-ups on the first day of November, 4 on the second day, 6 on the third day. So that we've got our little sequence building up. 2, and then 4, and then 6. Is it adding or multiplying each time? Adding. How much?
2.
So we're adding 2 each time. So that means arithmetic because it's adding. So nada. We said adding 2. That's D. A1, A0. So A1 was obviously 2 because it's listed right there. Then hypothetically, the number before that would have been 0 because it has to be 2 less. It has to increase by 2, which makes sense. She started doing pull-ups the first day. So like the last day of the last month, she didn't do pull-ups. Those are some huge gains though. Like impressive. Usually every couple of days, you can like 1 more maybe. All right. How many will she do on the 30th, which is the last day? So that's n equals 30 because it's the 30th. 1 through 30. Day 1 through day 30. How many will she do? So we're going to find the term. A sub n equals dn plus a0. Two times 30 plus a0 is 0. That's 60, which that also makes sense because she did 2 more each day. 2, 4, 6, 8, 10. 2 times 30 is 60. So 60 pull-ups, that's a lot of pull-ups for 1 day. I guess they're not all in a row. Maybe she does 2 and then comes back and does 2 more. I don't know. Or she's just ripped.
Yeah. I feel like Morris is like, Morris is like a grandma named Two.
Yeah.
So just imagine a rich grandma.
Yes. All right. So on the last day, she does 60 pull-ups. How many will she have done total when the month is over? So like you add up for the entire month, how many pull-ups did she do that month?
Too many.
Too many. Well, we know that there's 30 days, so the sum is what we're trying to find. N divided by 2, first one, plus the last one. We know all these numbers. 30 divided by 2, first day was 2, the last day is 60. So that's 15 times 62. 930 pull-ups for a month. That's a lot.
How many pull-ups does that average a day?
31 a day is the equivalent, which is still a lot.
Oh, like 6 pull-ups in 1 day?
Yeah.
I can barely do
I
2.
would have to go back to the pull-up mark quite a few times. Like, okay, you gotta take a break, I'll come back.
Just
Yeah.
do one, just do two, wait, does that actually make sense? Do two every hour for
Yeah.
24 hours? Or no?
2 every.
That does not make
No,
sense.
that'd be for like 30 hours. That wouldn't work. You did get stronger because you started and you were doing it all month long, so you've been practicing. So maybe you could do like
4.
at least 4, maybe even 10 at a time.
Sets of 10 seems reasonable.
So 6 sets of 10 pull-ups. I don't know. Or you're just completely ripped and you can just,
Just do 16.
you just yeah. That's what I do.
Oh yeah, how do you gonna do it?
I mean, I do it on the assisted pull-up thing, but
Oh. Makes more sense.
those are actually cool. Those ones that have the counterweights, those are actually really cool.
One of these days, we're just gonna see you walk in. You're just gonna be jacked.
His
Which means-
shoulder is like his neck is not his shoulder.
He does like a resistance band. He like stands on the band.
Yes. All right. Calculate the named term. So A12, find the 12th term. We got to know is it geometric or arithmetic though? Geometric. It's multiplying by
-30.
-3 each time.
You guys are smart. I didn't think.
First term is -6. That's really all you need. Well, n is 12. That's given to us here. I did it out of order. I normally write NAR, so whatever. NAR. All right. So to find the 12th term, the term for geometric is A1 times R to the n minus 1.
What is our?
What?
Making your pirate joke.
Oh,
She's trying at least.
Or
R.
what is our?
That's actually X, I think.
Yeah,
It's
so
sign language. It's sign
not in
Wait,
pirate language.
do you want to do
A1 over.
oh,
We're not finding the sum, we're just finding the 12th term.
yeah.
Oh, right. That's cool.
So to find the 12th term, we plug in A1, which is -6, and then -3 to the 12 minus 1. So -3 to the 11th is calculator worthy.
Ooh, yeah.
So it's going to be negative, big number times -6 is even bigger. Shocking. 106,2882 when you multiply that out. A million.
That's a good number. Imagine if you had that many.
He buys so many bananas.
No. You'd buy them at a farm. Let's change that. So.
All right, now to find the sum of the first 12 terms. So the sum is A1 1 minus R to the n over 1 minus R. So A1 still -6. 1 minus R to the n, so -3 to the 12. Over 1 minus -3. -3 to the 12th, the negative is going to work itself away. So it's going to be 1 minus 531,000 of 1 minus 3 to the 12th is negative 531,440. And then we're going to divide by 1 plus 3, then divide by 4. You get your car wash, and then go pick up buy one get one free Chipotle.
Dude, I have 8 coupons ready for the using. I don't know why I have 8.
That's a lot of trips to Chipotle.
You know what? I was talking to this one girl one time, and she said that she's not full after eating a Chipotle burrito. I can only eat
Wow.
huge. I can only eat like half, and I'm
Okay.
Yeah. You should only calorie wise you should only eat like there's like almost 2,000 calories in one whole burrito, so you should only really eat like half of one.
But they just said on their
Oh,
quiz
there's
that like,
almost 2,000 calories in it. Oh, well over 1,000.
dude, they just said in their quiz that like most of their meals have less than 600 calories. They were like so proud of
No,
them.
they do have options.
Oh, so sorry.
None of those options involve cheese or sour cream.
Okay.
those are like the best
I
parts.
know, I'm like, this is what I like. I'm like, what do you use? So,
All right, find the sum of the series. We need to know arithmetic or geometric. Looks like we're multiplying by 4 each time. So it's geometric.
Why is there plus sign?
Series means you're adding them all up. So we're
Oh,
finding the sum.
sorry.
All right, we don't know how many terms there are hidden by the ellipses. So we need to start with that. We got to find n. So to find n, we're going to take the formula. A1 times r to the n minus 1. And find out what we would need to plug in for n so that we get 16,384. So you could guess and check, try to like plug in a number for the exponent to see what it is. The actual math way of solving this out though involves going back to like chapter 5 and doing a natural log.
Why do we not like
I'd rather guess.
You go, so you could just guess. You could try like, okay, 4 to the, somebody said 13. 4 to the 13th is too big. 4 to the,
I'll go 7. It is 8.
yeah, so you could just guess. So 4 to the 7th
I went way too big.
is actually this number.
Did I get it? Second try?
No, it's 8.
Wait, is it 8 or 7?
It's 8.
So this number is 4 to the 7th, so that means n minus 1 is 7, which means n is 8. So you could do it that way. Or you do it the log way.
It's really
When you do the log thing, you move exponents to the front. This is on your final, so you might as well review it. Exponents move to the front. Divide. So in your calculator, you just have to type this in. Natural log 16,384 divided by natural log 4. And that tells you 7 equals n minus 1. Same thing we did the other way with some guessing, which means n is 8. N is 8. Now that's not the question. It didn't say what is n. It said find the sum.
So we have to add all of those numbers?
No, we have to use the formula for the
I
sum.
know, but still, it's gonna be huge.
It's going to be pretty big. So the formula for sum is a1 1 minus r to the n over 1 minus r. A1 was 1. R is 4. N is 8. So 4 to the 8. 1 minus 4 to the 8 is negative 65535. 1 minus 4 is negative 3. So those negatives cancel out. Two, 1, 8, 4, 5. That's a big sum. Because we had big numbers that we were adding up. Both chapter 8 and chapter 9 reviews need to be finished.
So N is 8.
N was 8. Yes.
Thanks for clarifying. That helps.
Okay, last example that we're going to have time for.
No, please tell the E.
Yeah.
It'll be recorded.
Oh,
Yeah, we'll check it. All right, a YouTube video gets 4 hits in the first hour, 20 in the second, and so on. So it starts with 4, then 20. Now,
You guys are so funny over there.
it is probably being multiplied rather than adding 16. They should have actually given one more example to clarify that you're not just getting 16 more. My guess is that this is multiplying because that's usually how like viral videos go. They multiply quickly.
If this happens on a test, like they only give us 2, are you gonna?
I'll clarify.
Okay.
I'll make sure you know. So it's getting multiplied by 5 each time. So getting multiplied by 5 again, the next number is going to be 100, and then 500, etc. So you could keep doing this until you get to the 8th hour, or it is geometric, so NAR. N is 8, A1 is 4, R, we said was multiplied by 5. So to get the 8th term, times R to the N minus 1. So that's 4 times 5 to the 8 minus 1. $300,000 views, pretty good. And that's just in the 8th hour. Plus all the other ones would actually be like how many views it's had all day long. Yeah. Probably not quite 1 million, but getting there. Getting there.
So for the word problems, want us to label them?
You should label, but I will not take off points.
What do you